Good morning. We will take down some more problems based on this Earth's magnetism, and we will finish this topic in today's class. So let us take down first. I'll give you the questions. Take down the first question, or question number A, or question number 1. Horizontal component of Earth's magnetic field at a place S root 3 times the vertical component. What is the value of angle of dip at this place? What is the angle of dip at this place? And now you take down another question. First I'll give you the question and then we'll try to answer both the questions together. If the ratio of horizontal component of Earth's magnetic field horizontal component of Earth's if the ratio of horizontal component of Earth's magnetic field to the resultant magnetic field at a place is 1 by root 2 1 divided by root 2 at a place is 1 by root 2. What is the angle of dip at that place? Okay, so for the first question, these are the two questions. First one is, we'll take down the first one now. Horizontal component of Earth's magnetic field at a place is root 3 times the vertical component. What is the angle of dip at this place? So I will write question number 1, solution. So first we'll take down the question number 1. Here what is given? Horizontal component of Earth's magnetic field is root 3 times the vertical component. Question number 1, it is given that. So first write down what is the given thing. Its given thing is that given horizontal component of Earth's magnetic field, that is BH. You can write horizontal component of Earth's magnetic field, BH, is root 3 times the vertical component. And the question is to find out what is the angle of dip. Delta is what? Now we know the relationship between BH, BV and delta. So write down first the relationship. Tan delta is BV by BH, or tan delta is, now substitute the value of BH, BV divided by root 3 BV. Why? Because BH is root 3 BV in this case. Therefore tan delta is 1 by root 3 or this implies delta is tan inverse of 1 by root 3, which is 30 degree. We know because tan inverse of 1 by root 3 is 30. Delta is 30 degree. The angle of dip at that place is 30 degree. Okay. That's about the first question. Now let us move on to the second question. If the ratio of horizontal component of Earth's magnetic field to the resultant magnetic field at a place is 1 by root 2, what is the angle of dip at that place? Ratio of horizontal component of Earth's magnetic field to the resultant magnetic field. So question number 2, given the ratio of horizontal component to the Earth's magnetic field, right? BH by B. The ratio of horizontal component of Earth's magnetic field to the resultant magnetic field. Horizontal component is BH and resultant is capital B. So BH by B is 1 by root 2. And we know that, we have the horizontal component BH is equal to B cos delta, or from this I can write BH by B is cos delta, or cos delta is BH by B. So what is BH by B? BH by B is 1 by root 2. Therefore delta is cos inverse of 1 by root 2. Cos inverse of 1 by root 2, which is equal to 45 degree. If you know the relationship between the horizontal component, vertical component and the intensity of total field with the angle of dip, you can solve most of the problems in this topic. And if you draw the triangle, so this is BH, this will be the vertical component BV, the resultant magnetic field is only B, and this will be the angle of dip delta. Okay, so now you may be asked to write 1 mark question, something like, where on the Earth's surface is the value of angle of dip maximum? You know that angle of dip is maximum and the maximum value is 90 degree and it is at magnetic poles. This is 1 mark question. Where on the Earth's surface is the where on the Earth's surface is the where on the Earth's surface is the value of angle of dip maximum? Value of angle of dip maximum. Where on the Earth's surface is the value of angle of dip maximum? We know angle of dip is maximum at poles. So you can write the answer at poles or at magnetic poles. The answer is, the maximum value is 90 degree and it occurs at poles, and at the equator the vertical component is 0, or angle of dip is 0 Angle of dip is maximum at poles, and at the equator it is 0. Okay, so this completes this topic. Hope you understood. So now in this, the important thing is to remember the relationship between the intensity of Earth's magnetic field, also the components, the horizontal component and the vertical component, and their relationship with the angle of dip. So if you know these formulae, most of the problems you can solve in this topic.